Like this? Yes. So good morning. Last session before the lunch, so need to keep focus. So now Peter will provide a talk, explaining how to use FHIR on Android to provide quality care in Liberia. So,
great. Thank you, Louis. My name is Peter Lubell-Doughtie. I'm from ONA, and as was mentioned, we'll be discussing how to use FHIR on Android for standards-based care in Liberia. We'll start with a bit of context on the project and how it can have impact, then talk about our overall approach to mobile healthcare on FHIR, and specifically look at ways we applied FHIR tooling in this project. So the goal of the project is to deliver high-quality care to Liberians with a focus on reducing mortality and improving the livelihoods of children under 5. The map on the right-hand side in here shows the number of children under 5 deaths per 1,000 births in Liberia. So it varies a bit by region. Overall, it's about 100 children per 1,000 born. And this is comparable to the Netherlands, or for comparison, where this number is 4 per 1,000. And in Rwanda, it's 39. In the US, it's 5. So you can see there's a lot of potential impact with this project. And the way we approach this is to register households in a smartphone app, provide workflows for reproductive, maternal, and neonatal care, specifically antenatal care and postnatal care, and provide child healthcare management workflows, childhood vaccination, sick child registration, as well as recording health commodity supplies and tracking and supervising healthcare workers. The map here shows the population density. So there's a large population in Monrovia in the dark purple, and then the population is spread throughout the country. Liberia has a total population of 4 million people. We will be focused on caring for the 2 million that are mainly outside of Monrovia. And for comparison, again, Liberia is 3 times the size of the Netherlands and has around a quarter of the population. So they will be cared for by 4,000 community healthcare workers, and those are managed by 500 healthcare supervisors. And it's critical that the approach we take is able to work offline. This map shows the mobile network coverage in Liberia. And as you can see, once you get outside of the capital of Monrovia, there's no mobile data access, effectively none. And most people that are going to be provided care for this project are within more than a day's range of an internet connection. So the platform, before that, just so you can get a little bit of a perspective on what this looks like in real life. The left-hand side is showing a community healthcare worker filling out the antenatal care forms for mothers who they're providing care to. So right now, these are paper registers where you will write a mother's name, track their services, manually manage the visits that they're supposed to go to, update the dates, and all of that work is done on paper registries. The blue here is a patient's childhood vaccination card or their birth registration card. So all of this work happens on paper now. The right-hand side shows a community health worker in the center using a smartphone app, and some of my colleagues working with them to help them use that application. So to build a mobile platform on FHIR, it's more obviously than just an Android application. That's a key piece of it that we're focused on, but this integrates with the platform of tooling that exists and the community of tooling that exists. We are building this OpenSRP application, which is layered on top of the Open Health Stack's Android FHIR SDK, using a FHIR data store powered by HAPI in the center bottom. And for authorization and identity management, we use Keycloak, and then an administrative web app connects to that FHIR data store. And we also synchronize with a data warehouse using Airbyte and Superset to derive analytics from FHIR data, and also from that FHIR data integrate with existing health information management systems, such as aggregate data systems or LMIS systems, logistics management information systems. Now, a bit more specifically into what is running on this platform. So if you were here for Jose's talk in the morning, he explained the smart guidelines approach that the WHO is taking. So this approach starts with FHIR as the underlying data model, and then uses the smart guidelines from the WHO. This is not the smart web interface, but the smart guidelines to structure the content that is going to then define the healthcare workflows in specific verticals. So we can take those smart guidelines and split them up, apply them to the project and country-specific use cases, And similarly to the last presentation, we're trying to combine those health and make reusable healthcare packages like Legos across different verticals. So, and one of those packages of FHIR content is defined by two main pieces. There's the user experience configuration, such as profile is what you see when you open up a patient. If I was to open a patient, how should that be rendered on the mobile device? If I am going to look at a list of patients, a register, which is defined as JSON encoded in a binary FHIR resource, defines what should be in that list. How would a panel of a specific list of patients look like? How would it be sorted? What are the queries that define those patients? And we use FHIRPath in those querying for both the registers and the profile views. We also have a set of healthcare workflows, questionnaires, PlanDefinitions, StructureMaps. So these two things get bundled up for a project and effectively define the mobile application. So those are loaded into like a mobile runtime, and they generate the look and feel and the state machines and the forms that the user is going to interact with. And as they interact with them, we run queries using the CQL evaluator, we render questionnaires using the SDC, and those then generate additional transactional data. So if I were to submit a questionnaire to register a patient, we would use the SDC to store a questionnaire response, run a structure map to extract patients, extract observations. We might run a plan definition through CQL evaluator, generate tasks and care plans, store that on the device, and then use FHIRPath to visualize those transactional data. Cool. So in a bit more depth, the left-hand side here shows a JSON antenatal care configuration that is defining a list of antenatal care patients. So just to review, so this would be defined as JSON, encoded as binary, put in a binary FHIR resource, uploaded to a FHIR compatible server, synchronized back down to an Android device, and then rendered on the mobile application to generate the middle screen, to generate this user interface. And then when you click on, say, let's click on that patient, and we go to a profile. So this profile is using FHIRPath to say, fetch the gender or the sex, render it, fetch the date of birth, calculate the age. So that's a FHIRPath expression in a configuration stored in a binary resource. And the reason we took this approach is that allows us to package up these healthcare verticals and to modify them as we go. So if we were to modify that FHIRPath expression on the HAPI server, resynchronize it with the mobile application, the user interface changes. On the healthcare workflow, so a similar type of application of FHIR tooling where you start with a questionnaire submission, we would generate a questionnaire response, and we can run through a specific example. In this case, we are showing a menu item for an antenatal care patient. And if you were to register them with a disease, you would fill out a form, and from the questionnaire response, you would extract some information. It would show that there are risk factors for preeclampsia, and then trigger, because it's matching a set of criteria, that you should run the preeclampsia plan definition against this patient to generate care plan and tasks. And then when you viewed the patient, you would see those tasks show up on their profile. So for example, that an abdominal examination should be shown, and that can be linked to a questionnaire defining the content of that abdominal examination. And on the right-hand side here, too, showing that in this profile configuration, we might say load the next upcoming task for each pregnancy patient and color code it based on its due date. We are also applying the CQL evaluator and quality reporting by taking measures written in CQL, then compiled to Elm libraries, and then bundled up on a FHIR server and synchronized down to the device. And we run those measures on the device using the CQL evaluator and the evaluate measure operation to create measure reports, so that in an offline fashion, the user can generate aggregate data, aggregate longitudinal data about their specific patients or all the patients that they have been seeing. Well, and we've been working closely with the CQL evaluation team to iterate on that tool so that it can run performantly on device. And we're at the point where it takes, I think, a couple seconds, but it's good enough to run on demand if the user's aware that they're going to need a pause in management. And we're also looking at ways to run it in the background without affecting user performance, but not there yet. Great. And so, taking a specific use case again, if one of the applications for stock tracking is to register when a community healthcare worker is conducting their antenatal care visit, they'll be providing medications, they'll be using gloves, using other commodities. So we want to be able to track that usage of commodities as they're going through delivering their services. So if they were to complete a questionnaire that noted that they have conducted a malaria RDT, we would have a structure map that would then extract from the questionnaire response an observation coded using the Snowbed code for a stock change. And then it would store that there has been a depletion of 1 for rapid diagnostic tests. And then on the FHIRPath register view of commodities, we could add up all those observations and show the current amount of stock. We also run evaluate and measure to aggregate over those observations that are related to stock for a specific commodity and produce a historical report, which is what's shown here, of the amount of stock on hand for various commodities. So these commodities right now are represented by groups because that was available in R4B. We're looking forward to transitioning to the commodity resource, which I think is in R5. And this screenshot is showing sort of an example of how we would apply FHIRPath. So the center screen, those 100 amount of paracetamol tablets available, that is in the configuration, the JSON configuration, there's a FHIRPath query underlying that's running against using the Android FHIR SDK to run against the SQLite database on device, aggregate observations, take, this is a depletion, so it says -1, this is maybe a restocking event, so it says +5 to get the currently available amount of stock. And the right-hand side is showing a questionnaire that comes up if you click on a specific commodity to record kind of non-service related stock changes. So if a stock was damaged or there was a restocking event, you can record that in this questionnaire, and then the structure map would extract those into observations that would then be aggregated. Cool. I'd also just to note that we make heavy use of the structured data capture library to enable clinical reasoning. The enable when expression lets us support skip logic. We use initial expression to load default values for question. The answer expression lets us load existing data into questions. So if you had previously entered some risk factors, or if you were editing a patient, we would use initial expressions. Actually, it's a little bit different. If we were editing a patient, we could use initial expressions, but instead we'll load questionnaire responses directly into questionnaires. And calculated expression to say, for example, we use this to sum up risk factors for diabetes to present like a diabetic risk score in some forms. Cool. And in this screenshot, we're showing that when you complete the Big Belly visit, which is the final antenatal care form for a pregnant client, if you were to say that they had danger signs, then conditionally a danger sign registration section would show, so you can enter those specific danger signs. Okay, and that's almost everything. So we have completed 2 pilots of this project in Liberia. We're very excited to be rolling it out to a national scale this quarter or next quarter. It's almost Q3. And we're also excited and been collaborating with the FHIR community on how to bring some of these edge cases that we found in this implementation back to the standard. One example of that is the group resource is what we use to represent families, but that's not, that's not a canonical, that's not really a semantic thing. So there's potential interest in having a family resource for that representation. Great. And finally, I'd just like to thank our partners in this work. Last Mile Health is the on-the-ground implementer in Liberia who's essential to making this project possible, funded by the Patrick J. McGovern Foundation, Village Reach, UNICEF, Digital Square, and of course, the Open Health Stack and its underlying toolset are critical so that all these pieces could work together. And if you're interested in applying it, please get in touch. I'm available also on Zulip under PLD. So thank you, everybody.
So thank you, Peter, for this presentation. Is there any question? Yes, there is.
Thank you, Peter. I have two questions. The first one is, the configuration you talked about, that's kind of on the top left in that screenshot, right? Have you considered making that into some kind of IG so that can be reused and other people can implement that as well? And the second question is, can you briefly talk about sort of how difficult or easy it is to write another application using the configs and the FHIR artifacts?
Cool.
Thank you.
Okay, thank you. Yeah, so we have, when we've talked to some members of the FHIR community about like what makes an IG, and one way to view it is it's the way you're using it defines an IG. So like we could consider this an IG under specific circumstances, but we are very interested in aligning this more with what is traditionally the IG structure, writing more of the documentation pieces which are missing for a lot of this. Right now, we're using the composition resource as the primary resource for this top left, and then that connects to a whole bunch of other resources. This is not like the normal way it's done in FHIR IG, so yes, we'd like to transition that to a more standard-based way. Also relatedly, for this UX configuration, like I mentioned, we're using binary resources. This would make more sense if there was a more semantic resource available in FHIR. There are some that come close, like list resource seems like it might be able to contain the register information that we want to encode, but doing both of those things, transitioning to a more acceptable, or more normal IG structure, and then converting binary resources to semantic FHIR resources are both things that we would like to do to make this sort of more self-documented and easier to share with other members of the community. What was the second question, if you don't mind reminding me? Right. Cool. Oh, yeah, of course. So the second question is how easy is it to take these bundles, built for a specific use case, and then reapply them to another project or another healthcare program? So, as we've been working on this project, we've been kind of iterating on how the configurations are defined, with the goal of making that easier and easier. So, and we're getting some data in like reapplying our own projects. So it depends. What we've seen is that in very narrow healthcare domains, it may be narrow in the sense of like a specific healthcare service. So diabetes management, we've had much more success taking diabetes management built for one specific country and then reapplying it to another country with tweaks to that configuration and content. For community healthcare, which is much more expansive, there are a set of different healthcare workflows that you're combining, ANC, EIR, and it's more challenging. There's more effort. So it's what we are doing that. It's totally possible, but the delta in LOE is going to depend on the healthcare vertical. And so we're trying to do, I guess, two things. Monitor per vertical, like how much time does it take to reapply from one to the other, and then overall see that number decrease over time, so that we're getting like good metrics on the ability to reapply, because that's a critical part of the impact is producing reusable content that can then be scaled, can be shared with others, applied to other countries. And we have upcoming work on an electronic immunization registry system with the WHO. Hopefully that will be addressing this more directly. How can you build a general package and then apply it to like a dozen countries or so?
Yes, please.
I think I can guess the answer, but do you have any responses from the users? How well is it accepted, and do they like it and things like that?
Yeah, so that's a great question, and it will go both ways. I will tell you. So in the projects where we work very closely with the community health workers and they see themselves as partners in the definition of the content of the workflows, they love it. They really like it. They see this as over time improving their efficiency and reducing the effort they need to put in to provide care. With the kind of caveat that there's a time period when they're transitioning from paper to digital where it's important to do both paper and digital so that you can have some verification that you're capturing data correctly. And at that point, you're increasing the burden of effort for them. But if they see the vision of long-term, this is beneficial, they're going to get better supervision and be able to provide better care, then they are very excited and happy to use it. Yeah, thank you.
Thanks. Yeah, just interested to know how the synchronization works, or is it one database per device, or do the devices get sort of plugged into some system later on if it's disconnected most of the time?
Cool. Yeah, great question. This is a piece of the structure that I kind of glossed over. So like effectively each device is a little mini EHR is probably the way to think about it. It has a FHIR store stored in a SQLite database. And the way it synchronizes is that so that, that little database, when it's connected to the internet, can synchronize with a remote FHIR API. So a generic proxy to a FHIR API that can then go to, in our case, it's going to HAPI, but any other FHIR API would be able to handle. For the offline data case, though, we have a P2P interface so that using a Wi-Fi direct connection, two devices can synchronize data between themselves. And then, when the way this works in the implementation is that, so a community healthcare manager would have, 5 or so, 3 to 5 healthcare workers that they're working with, and they'd all synchronize their devices with their manager. Their manager would then drive on a motorbike a couple of days travel to a place of internet connection, and then synchronize up to the cloud, synchronize back down to the cloud, and then they go back. The only way this works is that those clients that they're carrying are only in that location. So you could see there would be, potential for a lot of conflicting data here, but thankfully right now that's offline. The communities are distinct, so those conflicts don't happen. We are definitely trying to plan for a future where you do need to do conflict resolution and data deduplication and those types of services on the server side and potentially also on the devices. Thank you.
So thank you again.
Great.
Please register feedback if you have the opportunity, and then I wish you have a good lunch and a good further session this afternoon. Thank you.
Thank you. Cool.